Okay, let's finish up the rest of these notes. We are going to do number 11 in class, so I'm not going to worry about that one. I know you're probably curious about 10 and 11, but we'll do one or both of them in class. Okay, so reading the notes from here, the degree of a polynomial function indicates the maximum number of real zeros of the function. So that's one thing that we didn't talk about when we were looking at these functions earlier, is that the degree tells you the maximum number of times it could cross the x-axis. So for example, if this line has a degree of 1, it could, it's going to cross the x-axis one time, at most. This one has a degree of 2, so this graph could cross the x-axis twice, at most. This one has a degree of 3, so it could cross the x-axis 3 times at most. And that's the way it works. The degree tells you the maximum number of times that it could cross the x-axis. It doesn't always have to be exactly 4 times that it's going to cross the x-axis, but that's the most it can. Okay, now the next part talks about the turning points. The minimum degree will be 1 more than the number of turns the graph makes. Okay, so let's talk about turns of a graph. Let's say we had this graph, the cubic function. Okay, it crosses the graph 3 times, so the degree is 3. That's the highest degree it can have. So if you trace your graph from starting on the left side, it's going up. The graph is going up and up and up, and now it's starting to get flatter, and now it's starting to come down, it's starting to turn, and it's coming in the direction, so it made a turn. So this part right here is a complete turn for the graph. Now it's going down, and it's starting to even out again, and now it's starting to slowly start to go back up, and you have another turn. Okay, so sometimes you don't have a turn, even though it kind of curves around. It has to completely change the direction that it's going. So if you have something like this, where it's curving, it's making a shape, but it's not turning. There is no definite turn where it starts to go the other direction. So that would not be considered a turn. This would be concave, and well, we'll get into that another time. I don't want to get into that right now. Okay, sorry about that. So let's go back to the notes. Starting right here. Okay, so we've already said this. The degree indicates the maximum number of times that the graph will cross the x-axis. So if the degree is 2, then it could cross up to 2 times on the x-axis. Now we're going to talk about end behavior. The end behavior of the graph, if it goes up or down, is determined by the leading coefficient and the degree. So I want to explain that to you without reading through the notes, because the notes get a little wordy. So on your graph, on the right side of the graph, okay, the bigger your x value gets, the higher your y value is going to be getting on this graph in particular that I'm looking at. And so on the right side, your x-axis or your x values are always increasing. They are always getting bigger. So you could say on the right side that x is approaching positive infinity. And the arrow right here means approaching. So x is approaching positive infinity. That's all the parts, what that means. On the left side of the graph, and this is always true, on the right side of the graph, x is always going to positive infinity. On the other hand, on the left side of the graph, x is always approaching negative infinity. Okay, so x, the arrow means approaching negative infinity. This is always true on the left side of the graph. So your x is always going those directions on the right side and the left side. That never changes. So, and we're going to use that to talk about end behavior in just a second. So your end behavior is determined by the leading coefficient and the degree of your function of your equation. So let's do a little example here. I'm just going to make a chart for you guys. So you might want to maybe do this on the back of your paper or something. Okay, so let's say I have y equals positive x squared. Okay, so your leading coefficient is a positive 1. Sorry, you couldn't see that. Leading coefficient is a positive 1. And really, whether it's positive or negative is more important than if it's a 1 or a 2 or a 3. So your leading coefficient is positive, and the degree here is 2. So what that means is, since the leading coefficient is positive, on your graph, the right side is going to go up. This is just talking about end behavior on your graph. Since the degree is even, the left side is going to go the same direction. That's what we talked about on the first video earlier. Okay, so now let's say that your y is negative x squared. So your leading coefficient is negative. The degree is 2 still. It's even still. Maybe I should put even instead of 2. That's more to the point. So, on your graph, since the leading coefficient is negative, the right side is going to go down. Since the degree is even, the left side is going to go the same direction. Okay, so what if you have an odd degree? Let's say f of x, which is also y, equals x to the third. So your leading coefficient is positive. Degree is odd. So since the leading coefficient is positive, the right side is going to go up. Since the degree is odd, the left side is going to go down. Okay, f of x equals negative x to the third. Leading coefficient is negative. Degree is odd again. So since the leading coefficient is negative, the right side is going to go down. Since the degree is odd, the left side is going to go the opposite direction, which is up. That's the way that the graphs always do. It depends on what their degree is and what the leading coefficient is. So let's do a couple of examples describing end behavior. Okay, here's number 12, and it wants us to describe the end behavior, state the maximum number of real zeros, and state if the degree is even or odd. So first of all, since the ends are going the same direction, then this degree has to be even. State the maximum number of real zeros. Well, real zeros is just how many times is it cross the x-axis. So the maximum number here is 2. So you'd say real zeros, 2. And then describe the end behavior. So let's start with the right side. The way you describe this is we talk about f of x and x. So f of x, the arrow means approaching. Now f of x is your y, and in this case y is going down. So f of x is approaching negative infinity since it's going down. As x approaches on the right side, x is always approaching positive infinity. Okay, on the left side, we start with f of x again. F of x is approaching, again, it's going down, and when the graph is going down, it's going in the negative direction for your y. Negative infinity as x approaches, and on the left side of the graph, x is always approaching negative infinity. So I'm just talking about the very ends of the graph. I'm not worried about anything in the middle. I'm just telling you what direction the graph is going in reference to y and x. Okay, so let's look at 14. Here's your graph. Okay, the degree here Just to recap what we talked about in the first video, if the ends are both going the same direction, it's an even degree. If the ends are going opposite direction, it's an odd degree. So this degree is even since they're both going up. And then real zeros means how many times does it cross the x-axis? None. There are no real zeros. And then the other part is to describe the end behavior. So we want to talk about f of x first as x second. So I'm just setting it up really. Talk about f of x first on the left side and x second. Right, so now I'm just going to say if it's going up or down, and that's what the infinity tells us. So since the graph is going up, the y value is increasing, so that means that the f of x, the y, is going towards positive infinity as x approaches positive infinity. Now on the right side, x is always going to be positive infinity. On the left side, f of x again is going up, so it's approaching positive infinity as x approaches negative infinity. So the one that you really have to think about and decide which direction it's going is the f of x. That's the one that's going to change. The x's always stay the same. On the left side it's negative infinity, right side is positive infinity. So I'm going to stop here, and you guys just kind of sit on that, write down questions you have. When we come to class on Monday, I'll do a couple more examples, and then we'll just start on our assignment from there. Okay? All right, see you then. Have a good weekend. Bye.